Recording has started. Alright, so this is your basic interface. Now in this software there are various workbenches. Okay, so if you click on that start button, you will see all these various workbenches. That is part design and FEM. These are the key workbenches which you will be using. So in that, select part design. Alright. Now after that, go to this create a new body and make it active. I click on that icon and go to this model tab. There are two tabs in this. You will see this combo view. So in the combo view, there are two tasks and model. So go to the model tab. So you should see this icon of this body. It says body. All right. Everybody is on the same page as me. If I'm going too fast or something is, if you're lagging, just let me know immediately. Okay. Now click on this sketch button. Okay. Create a new sketch and click on XY plane and click OK. All right. So if you see this interface, there are these icons on the top. All right. So if the icons are hidden, just drag this task bars and adjust it so that nothing is hidden. All the task bars are visible. Okay. Now initially this was, if you in your software, this might be in this horizontal position. So take this taskbar and I like to arrange it in this way. Okay, it is up to you, but it is convenient for me to do it in this way. Okay. So these icons on the horizontal taskbar, these are all the construction icons. Okay, so these are used for doing line or a arc, circle, etc. Okay, and the vertical ones, these are constraints. So we'll see what is how are they used. So just click on the circle icon and click on the origin and draw this circle. Okay. Now click on the constraint icon with the circle. Click on it. Dimensions. It's time 25. Okay. So when you type the dimension appears. Similarly, you can draw. Just delete this. Similarly, there is another option that is for line. Now, whenever you are constructing this, any of this, making this construction, you will see that there is an icon which is appearing on the screen, which is the constraint. Okay. So if you are more or less vertical, then this will constrain the object to be in vertical direction. All right. So this is for drawing line. Then this is for arc, center, and 1 point, 2 point. All right. Then the one most important one is this is called as the polyline. So in this polyline, you can just go on constructing the lines continuously. Okay. And now if you want to change this from straight line to circle, just press the M key till the arc appears. Okay. So if you can see, now the arc appears, so you can construct the arc also. Okay. And again you can change it. Change it to straight line. And this is. Right. Then you can give the dimensions of this on this. So let me just a different one. Go to the polyline. Select one. Here, vertical. Then change it. Press M. Change it to circle. Over again. Press M till you get the vertical line, and then just close it. Now you can use this. Now if you see on this task model window, Now it says under constraint sketch with 3 degrees of freedom. Okay, so this if you see this object, it can move. Okay, it is only fixed at origin, so it has 3 degrees of freedom. So now if you apply some constraints, like, okay, so what I want to do is make sure that when I move this object, this right now, see this, if I move this line and this line becomes unequal. So what I am going to do, select these 2 lines and apply the constraints that so that they are always equal. Okay, so click on the equal button. Alright, so now if you can see the degree of freedom has reduced by 1, and if I just still click on the object, still it can move, but now it can move in 2 direction, but this length remains constant. Alright, so now I want to restrict that also. So what I will do, just give the dimension for the circle, say 20, and click OK. Right, still it has 1 more degree of freedom. It can still increase in height. Okay, so now what you can do, you can give the constraint in vertical direction. So click on these 2 red dots, 1 and 2, and click on the constraint, the vertical eye. Okay, and you can give the dimensions. Say suppose it is 20. Right, so you can see the dimensions are appearing on the sketch. All right, and now if you can see in the model window, it says that the sketch is fully constrained. All right, everybody on the same page till now? All right, now you can close the window. Now we'll see some options, like there is one option called padding. So if you click on pad, then it just extrudes the face. Okay, click OK. Okay, and it is the dimension is 10 mm. Okay, now if you want to go back and change, you can double click on this. Okay, if you want, say suppose you made a mistake and actually it was 15 mm, so you can make it 15 mm. It updates the object. Right, so this is just the basic interface, and I would like to what do you say, go through couple of more, that is the sweep and extrude, sorry, sweep and loft. Okay, so we'll see uh, those. I'm just going to delete this. So let's see one more option, that is the loft part.
So your screen share is off, I guess.
Yeah, just a minute. All right, is it visible now?
Yes, sir.
Oh, so again go ahead and click on body. So this body should appear here, and then click on sketch and select the XY plane and click OK. and then you can go on model, and if you see this, there are this various details of the object, and here you can see it is that origin. Okay, so if you select on origin and paste the space bar, then the plane appears. Okay, you can toggle it on and off by using the space key. Okay, if I hit the space key, see it is unhighlighted, then it is off. If I want to see that, no, just hit the space key and it should become off. All right. Now what we are going to do, we are going to create a loft. So just sketch some circle, and no need to worry about the dimensions and all, and go to task and just close it. Right. So the circle was created on XY plane. Now let's go to again create a sketch and go to XZ plane. I am choosing a plane which is perpendicular to it, and click OK. Right. And want, you can switch the origin off. Okay, and just let me sketch approximately a rectangular shape. Okay. And go to task and click OK. Right. Just click anywhere on the screen such that none of the screens are highlighted. Now there is an option for loft. Okay, so select this option. Everybody with me, if you are lagging behind, you will let me know immediately and just ask me to slow down or something. Okay, then select one sketch. Okay, and click OK. Right, and select the second sketch. See, click on add section and click on the section. So now the section is added, and click OK. Right. So basically what loft does is it joins any two sections. Okay, now I have just randomly done this activity, but when we are going to create models, we will see how this can be used. So this is one way to create the loft. Now another way we'll see, just delete this. Okay, again go to body and then create sketch, and create sketch on XY plane and click OK. And again we'll draw a circle and close. Okay, then again go to sketch, again select the XY plane, same plane. Now what we are going to do is we are going to loft with parallel sections when the sections are parallel. Right, and click close. Right. Now after this, go to change the workbench from part design to part. Right. And go to this option, creation of parameterized geometric primitives. It creates primitives. Click on that and click on plane. If you want to increase the size of this plane, if it is too small, create. Create and close. Everybody with me on this one? Can I continue? Okay, now again change to part design and go to model, click on the plane and click on the placement, and click on the position and click on the Z and make this say 100. Okay. So if you see from the front, the plane has now shifted up. Okay. Everybody with me on this one? circle and the rectangle both are on the same plane. Now I want to move one of the sketch on the other plane. So select this, select the sketch name from the list. So select the one which you want to move. So I'm going to select sketch one, the second one, and click OK. And again, it is select. Okay, all right. We got this. All right. Now we are going to loft these two sections. So click on loft. Select sketch. Select add section. Just loft. Okay. Add section. Add section. All right. And click OK. Loft between two parallel planes. All right. So these are some of the basic steps, that is lofting. Now similarly there is one more option called as sweep. So we'll see that also, and then we'll move to the actual. Just create a new one. So next we will see this sweep option. Right. So again go to click on body and select create sketch, and let's create it on XY plane. And I'm going to use the polyline to create a sketch. And okay, now here go to edit and go to preferences, and here go to the units tab, and from here you can change the units to inch pound system. Okay, so I'm going to change that. So now the units will be all in inch. Right? So click on the polyline option and create a sketch. R. Okay. So we have created a sketch. Now we'll put some constraints on this and make these two equal. This I will make it as horizontal. Now we'll give some dimension to this. Select these 2 points and select vertical I, and I'm going to make it as 0.125 inch. So if the dimension is not visible, just drag it and slide it, and then I'm going to make these two also equal, and I'm going to dimension this. I'm going to make it as 0 0.0. Just a minute. 0.5. This is these two lines are not remaining vertical, so select these two and add the constraint, and then it makes it vertical. Now if I suppose this is just too big, the thickness is too much, so now let me just first modify the thickness of the top one. So let this be, instead of 3, let's make this as 1. Now I will just reduce this to point, right? So as you can see, the section is there, and if I want to make it a little bit more thin, 0.4. Okay, so this is the section. Now this is the section which I want to, what you say, sweep. One more constant. Okay, the height is still not fixed, so I'm going to select this one and this one. Select the height, and let's make it 1 inch. Right. So this is the section I am going to sweep, and to sweep this section I have to define a path. Okay, so I will just, now if you can see, this sketch is fully constrained, so close this. All right, now we're going to do one more sketch, and we are going to choose a plane which is perpendicular to it. So we are going to sketch on the plane which is perpendicular to it. So we are going to sketch it somewhere like this. I'm just going to go to the model task and just go to the front. So now what I want to do is I want to sketch the path at midpoint of this. All right. So what I need to do, I need to import this. See, right now if I want to select this as a reference, I cannot do it. So I want to import this. All right. So I get some reference line. Go to front, and just I'm going to trace the sketch the path. So go to polyline, select this one, and see now this constraint appears. So make sure you select the appropriate constraint, or you adjust the mouse so the constraint is proper. Okay, and then click on the M button on your keyboard, and that toggles the type of section that is editing. Okay, so this is quarter circle. Now I want again horizontal line, so again type M 2 times, and again I want circle, quarter circle approximately, select this, again type M, select them, and make sure that is vertical. Alright, so this is the path. Now I will just give some dimensions to this path. So I want this to be in the center, so let me just first adjust this whole, let me just first give some dimension. Okay, you can for zoom you can use the mouse roll button. For panning you can just press on the wheel and just pan the sketch, right? Okay, now I will make this distance as 4 inch. Okay, I can just drag this over here. Alright, so this figure is getting distorted. So what I can do now, I have to apply few more constraints. So I will make these lines tangent. So this is the constraint for tangents. Okay, and again this and this should also be tangent. This and this should be tangent. And this and this should also be tangent. Okay, and let's make before that, let's make these two equal, like equal, and then make this tangent. This should be tangent. Okay, all right. Make this. Okay, just drag this endpoint. Let this be 2 inch. Okay. This radius and this radius also I am going to make it equal. And this I am going to change it to 1 inch. Okay, so this is still moving in. So 1 degree of freedom is there. So I will place this path in the at the midpoint. So I will going to, so the total width of the T was 1 inch. So select these 2 points and change the horizontal distance to 0.5 inches. Okay. Alright. So now this path which I am going to sweep, used for sweeping, is exactly at the midpoint of the T. Alright, and just click close. Right, and click anywhere on the window and just click on the sweep icon. Okay, so select sketch as OK, and object to sweep as this one, and click on add edge.
Sir,
Yes, yes, please. Yeah, go ahead, go ahead.
no, sir.
Yeah, I cannot hear your question. Okay. let him come back with the question. So again, click on add edge and go on selecting the edge, add edge, and select this complete. After this I will just take a break, and then we'll address some of the questions that I have, that you have. Okay, and click OK. Okay, so this is the sweep command. So you can create these kinds of complex geometry using this sweep. All right. Yes, yes. So now let's stop for a few minutes, and if anybody has some questions before proceeding to the FEA exercise, let's have those questions. Somebody was asking some questions. Question. You might not be able to grasp this quickly because this is a new software, and uh, maybe somebody needs to uh, have somebody is doing something, or like, I will just for a few minutes I will just discuss about why to use why I am doing this on FreeCAD. So basically FreeCAD is an open source software and it has a free commercial license, right? So like many of our students have the what you say the they are entrepreneurs or they have their own businesses, so you can do your own consultancy, and there are no, you don't have to pay any charges for it. All right. And the second thing is that I've if you compare this software with any of the other software that you have learned, that is SolidWorks, or you will find that this is on at par with those softwares. And I'm just doing some basic stuff now, but we'll be doing really complex geometries and FEA analysis of really complex models as we go along with the workshop. Okay, so that is one thing. And another thing is that the FEA component is not outside of this software. Okay, like for example, for ANSYS, the modeling part is very restricted. I am taking for example as an ANSYS. Okay, so generally what is done is you make model in some other software and then you import it. Okay, and we have those have some experience with using this CAD software. You might know what kind of difficulties we face while importing this geometry. So here that issue will not arise because the FEA component is this workbench is included in this. Okay, so that's why you will find that there are very few glitches while using the software. All right, so this was just a basic introduction of some of the basic features that you will be using. If you have any questions, you can ask me. If you need me to change the way we are doing this workshop, you can ask me about that also. If you are stuck on something, you can ask me before I proceed to the FE exercise for the today. Vaishnavi,
Yes, sir.
yes. Uh, are you able to follow? Are students able to follow this exercise?
Uh, can everyone raise their hand if the pace is okay for them? We haven't received any messages from anyone, but
Oh, okay. All right. If anybody says has any issues or any messages, I think most of them have raised their hand. So I guess we are okay to continue. Okay. All right. So now stop sharing. I'll just close all this. Close. And we'll start with the FEA component. Let me just stop scribing for a minute. So today we will not be doing a very complex geometry since it is the introductory section. We are going to do FEA on snap ring. Let me just set up a few things. All right. Okay, I'm just stop the share screen because I need to set up some few things. So let's first try to understand what do you mean by a snap ring. All right. Can everybody see the slide?
Yes, sir.
Okay. So let's first. So what we are going to do today is the FEA analysis of snap ring. All right. So this is the snap ring. I can see this, and uh, you can see this is assembly of a spline shaft. So at the end of the shaft, there is a bearing, split retainer, a retainer ring, and on the top there is a snap ring. So the snap ring, these are like the metal fasteners. They are, and you will see that there is a groove on the shaft, and uh, they're installed in this groove to retain the assembly, so that this assembly should not by some reason if it slips out, it should not slip out of the shaft. Okay, so this is a preventive apparatus, and it is just pushed on to that groove. Okay, so no, we are going to do FA analysis for that. Okay, so we are going to everybody is on the CAD window. So first click on body, and then click on sketch, and click on XY plane. Okay, and now we'll start sketching on the XY plane. So go on select this arc option, 2-point arc. Okay, okay, now before that let me change the units before starting. So for this exercise we are going to use the MKS system. So go to edit. Hello. Yes. Hello. Somebody was saying something. Go to units and change to standard mmkg s degrees centigrade, second degree centigrade. Okay, because for the last exercise we use the what you say inch as the unit for the distance. So here we are going to do it in millimeters. So change that. Okay, then select on 2-point curve. select on 2-point curve, select the center and click on the vertical axis and go down and click here and repeat the same thing here. Click on the vertical axis here and somewhere over here. Okay, again click on the center and click somewhere over here. Right, and click on the endpoint, and since there is no degree of freedom, you can just drag and adjust it a little bit. Right. Done with these three steps.
Yes, sir.
Okay, right. Okay, and then close it on the vertical line. Just zoom it using the mouse, roll it, select one endpoint and the other endpoint and close it. Okay. Next, we'll define the radius for these arcs. So just go on radius, and the outer one is 5. Click OK. The second one is 22. Click OK. And third one is 27 and click OK. Right. Just move this. I'll delete this and just make this once again. Go to arc, select the center and click here, and now click on this arc and select the dimensions and make it 27. Okay, so not an issue. All right, and you can move this dimension so that it doesn't clutter your work. You can move around these dimensions. Right, now join these endpoints. Select on the, press the middle mouse button and drag it and select on this line and click here and here, here and here, and right click to end the command. Select both this and make it vertical. Right, now we are going to make some distances. Okay. So now let's mark the distance of this vertical line from the reference line. So select on this point and this line and the horizontal and type 2.5 and click OK. And click on this outer line, this one and this line, and on the horizontal distance and type 5.2. Okay, right, just see this dimensions are getting mixed, so I'm just going to drag them so that it doesn't create a clutter. Just keep it over here. I'm sorry, just this change this to 8 actually, not 5.2, 8. Right. Okay, so after this dimension, just see the sketch is fully constrained. Not necessary that it should be always constrained, but it is some helpful. So just close this. Okay, so you got this sketch. Now we are going to extrude this. So go to this pad option. Okay, and make this make this 2 and click OK. All right. Okay, so this is the extrusion. Now we'll cut a hole on this surface. So again go to sketch on XY plane and click OK. Right. And if you want to make this instead of solid, you can go to this option as is, and from as is change it to wireframe. And go ahead and click and construct a small circle over here. Okay. And the circle is now free to move anywhere. Okay, so now what we are going to do is going to give the dimensions. So click on the circle and give the radius as 1.5. Click OK. And select on the vertical dimension, select on the center and the x-axis, and make it 23.7. Click OK. And click on the center and vertical axis, and click on the horizontal dimension and make it 5 point and click OK. All right. So after that is done, we are going to cut this hole. So just close this. Okay. Now go to this icon, create a pocket. Okay, and click on it. Pocket. And change this to symmetric to plane, and dimension is your dimension, change it to through all. Okay, and click OK. Okay, now if we change this to as is, you can see that this is a hole which is cut. Everybody on the same page?
Yes, sir.
All right. Now what we are going to do, we are going to make a copy of this, and we are going to orient it in this way so that this is a symmetrical uh, half part is generated. Okay. Now before doing that, we'll add some features to this and make some fillet. So select on this edges, select one edge, and use the control key for multiple selection. And go to the fillet option, and it is 1 mm, so select, we are going to keep that as 1 mm and click OK. Okay, so this gives it a nice fillet. So the edges should be smooth for when you are pushing the snap ring. Okay. Okay, now change from part to part design to part. Okay, and select on this fillet, click on this part, and select this, create a simple copy. Okay. Then again go to part, and again create a simple copy. Alright, now switch, press the space bar and switch this fillet off. Okay, now click on the second fillet and go to this position and axis and change it to y as 1 and z as 0, and change the angle to 180 degree. Alright, so now if you can see, the part is on the other side, but now it is below the other part. Okay, so what you need to do is adjust the position, and so go to this z and change it to 2. Right, so now you can see the parts are aligned. All right, okay, now select both these, fillet 1 and fillet 2, and go and click on Boolean fragments. Okay, and then click on this Boolean fragments and change the mode to compound solid. Okay, now Boolean fragments, and we are going to check the model integrity. So click on the model integrity button, analyze the geometry for error, and click on run check. Okay, and expand this shape content. So here it is saying compound solids and compounds. So we don't want these compounds, we just want only compound solids over here. So that the whole snap ring is treated as a one single entity. Alright, so we'll just close this. Okay, let's close this and select on this Boolean fragments, go to part and go to this compound and click on this compound filter. Okay, now again select on the compound filter, again check the geometric integrity for check for errors, do a run check, select the shape content. Now you can see there is it is only one compound solid. Okay, that is how we want it. All right. All right. So now it is a one entity. Everybody is on the same page. So next step is to start the FEA analysis. So hello. Yeah, I didn't get the question.
If it is one whole compound, then the edge would be disappeared. But in this case, we are seeing that edge.
You're seeing that edge, but the part is now a single part now. Okay. This edge why we have kept, because we need that edge for giving the boundary condition. Okay, so when you push this snap ring on the shaft, the both part will this portion remains what you say more or less fixed. You hold that in your hand, and so that part is more or less fixed. All right, and these two ends are expanding. So there will be a force on force on this face and this face, the ones which are highlighting, and it will be equal and opposite. But this part, so it expands everywhere, but here it remains fixed. All right, so to do that, we need this reference line. Okay, because now we are going to give the boundary condition. So for that, we have done it in this way.
Okay, sir.
Now do right click and click on fit all. Right. Yeah, okay. Now let's go to the FEA part. So click on part and click on FEM. Okay. Okay. Next. So the menu is now going to change. So now this workbench is for doing your finite element analysis. Okay. So now there are certain steps you need to do. So first step is click on this analysis. So this analysis will include this solver. This is called as Calculia X. So that has to be first included. After you include that, you have to include the you have to give the material properties. Okay. So click on the material icon. So this is this button, and click on that, and this material window will appear. Now there are some standard material defined in the software. So we are going to take for this exercise calculi x steel. Okay, and the properties will appear on the window. You can go through the properties. Density 7900, so it is the density of the steel. Young's modulus 210 gigapascal. We are very familiar with this number, especially for steel, and Poisson's ratio is 0.3. Okay, right. So once the material is selected, just click on, scroll down, and just click OK. So now we are going to give some constraints, and for giving the constraints, we are going to use this some various faces of this geometry. So for giving constraint, we are going to click on this creates FEM constraint for displacement acting on a geometric entity. So click on that and select the lower two faces. One, click on add, select on another one, click on add. Okay, so add these two faces and fix it in the Z direction. Okay, and click OK. So once it is fixed in the Z direction, see this symbol appears as the model is fixed. You can see it in the front side. All right. Okay. So few more constraints we need to give. So one by one we'll give the constraints. We have to give the constraints in X direction and Y direction. So for that we are going to use this edge now, which was created. Select this edge and click on select on this edge and click add. And make it fixed in X as well as Y. And click OK. All right. So the constraint appear. So as you keep on adding the constraints in the model view, the constraints will start to appear one by one. Okay. Constraints over on the object, and you can observe the constraints. Now if you want, if it is, now we are going to give some more constraints. So to avoid the clutters, what you can do, you can select the two constraints 1 and 2 and hit the space key and switch it off. Okay, now we are going to give some more constraints. Right, so I'm just going to switch that off. Right, so again go to constraints and select the edge and click on add. Very well. Click on this one, add. And X displacement is fixed and click OK. Okay, so all the constraints are now given. Now we'll apply the force. So we're going to apply force on these two faces. This one and this one. Okay, so select this and there is this icon for applying the force. Click on that. Okay, so click on the face and click add. See this symbol for forces. Now we want the force in opposite direction, so reverse the direction and give the force of 230 and click OK. Similarly, select the second phase, click on no need to click on that, click on add. Okay, click on the face, click on add and again reverse the direction and type in okay and click OK. Alright, so you can see the forces are in opposite direction. That's how the forces will act on the snap ring as it is inserted in the groove. Alright, so forces are all given. Now we'll have to mesh this geometry. So go to the top one, compound fender, and there are these two icons on the screen. So click on G mesh and we are going to control this geometry by giving some specification. Right, so we are going to keep the max element as 1, minimum as 0.1 and click apply. Right, so the geometry is meshed, but it is giving some warnings. Okay, so we'll see about that. Okay, so click on OK and expand this and here you will see the mesh generated. Okay, you can toggle it on and off by pressing the space key. Alright, so now the mesh is generated. Now you have to solve this whole equation. Alright, and so what we are going to do, so to solve this you have to go to this solver tool. So click on that, and let me just expand this, and there are these various options. So if you see, just expand this, geometric nonlinearity, so it is by default it is linear. Okay, and double click on this and click on write input file. So write input file is complete, and then click on run calculate x. I'll just come back in 1 minute. Alright, so everybody should get this message, calculate x done without error. Is everybody getting it? Has everybody got it? Hello.
Yes, sir.
Okay, now then close this window. Now we'll see the results of our analysis. So click on this and click on this icon. That will give you the visual, that will help us to visualize this result. Okay, all right, and so this will give you the displacement, and here see minimum and maximum is shown in this window, so that will give you the minimum and maximum displacement. Okay, you can also just do this and click on change this factor to 1, this also to 1, and so this will give you the, as I increase the, what do you say, the snap displacement on the snap ring, how are the stresses generated. Okay, okay, and you can, if you want, you can go to this compound filter. Okay, let me just close this, go to this compound filter and go on appearance, and you can make this appearance transparent as much as you want, just to avoid any clutter while visualization. Okay, again go to CCX and visualize the result. Right. So this will give you how the snap ring will deform as it is inserted on the shaft, and how are the stresses generated. All right, so now we'll try something else. Okay, so again go to the solver. Okay, and now so if you see the geometry of the object, there is lot of non-linearity. Okay, it is not a linear object. Okay, so what we are going to do, instead of this, we are going to change this linearity, geometry linearity. Instead of linear, we are going to make it non-linear, and double click on solver, do the right input. Okay, and run, click on again run calculax. So as you can see, so did you see the difference? What happened just now? Can anybody tell me?
That
Our
was measuring inside face also.
Yeah, and also if you see, remember the earlier one, it threw out some errors, right? There were some errors which were displayed, but now in this case we did not get any errors. Okay. All right. Now let's now you can again do the same types of analysis. Click on the result and go to the FEA, and this will give you the similar type of results. You can also go for the stresses induced. Okay, maximum principal stresses. Okay, maximum shear stress, and you can see this slider and can identify the results. All right, everybody is on the same page. Everybody is able to get these things. Before I go to the next part, all right, now again click on, see now the I want the what do you say, the I want to display the result more specific manner. Okay, so what I'm going to use, I'm going to pipe this result. So for this I'm going to use this pipe option. So select on this result and select on this uh, icon which says creates a post processing pipeline from the result object. Okay, and click on that. Okay, and double click on the result pipeline. Okay, now here select the mode as surface. Okay, now none of the field is selected over here, so go ahead and change it to displacement. Okay, so if you see now the model gives me more information. Now you can just move this to side. So these are the various stress values which are color coded, and accordingly what are the various displacement on this model are displayed. You can also see the stresses, for example von Mises stresses. So it gives you the graphic, it gives you a better picture in terms of where the stresses are. You can select the stress, so you can select it with the nodes also. Give you the stresses at the various nodes and the displacement, right? So you can see that this is the red area is the area where the displacement is maximum. All right, so in this way you can interpret the results. All right, any questions? All right, I think we'll stop today's session over here. And we'll rejoining again tomorrow and continue with the exercises. Any questions before we end today's session? How many of you are able to do this exercise? Please raise your hand in the chat box. How many of you are able to complete this exercise?
Hello, sir.
Yes, yes.
Can you use the dimensions of the object?
You want the dimensions, of overall dimensions of the object?
Yeah.
Yeah, I will send it to you on to Vaishnavi on WhatsApp, and then she can give it to you. Is that okay?
Yes, sir. Thank you.
Uh, Anybody else? Anybody else who is facing any issues for while using the software?
So while using the same model in other software like SolidWorks and using the same dimension and the same material and using analysis in NSYS, then the result which we got from NSYS is in how much harmony with this result which is shown by FreeCAD. If there will be same or it will be
It will be
different,
same.
if any.
It will be same. All the properties are same. There is no reason for these results to vary. So generally, how do you do the analysis? You do it in you do the modeling in SolidWorks, and then import the geometry in ANSYS. Is it?
Yes, sir.
Okay. So have you experienced any issues while doing that? Because when I used to do this kind of thing, the many times I used to face the issue that the geometry would be imported incompletely. That was a common issue that I used to face while using FEA software. But here the FEA component is native itself to the modeling component. Okay. Any other question? So how many of you are comfortable with using the software? Of course, I will be providing you will be all getting the recording of the session. So this is what you should do so that I also will get some feedback on how much uh, students are able to absorb this. So what you have to do, whatever exercise you have done, just create a PDF, go to file and to print and just go to the Microsoft print or any PDF printer you have and just print this document, and I have created that assignment for today. All right, so on against that assignment just upload it so that there is no evaluation of that assignment or anything. I will just get a sort of feedback on how much you have learned. So you don't have to just upload the model. So we have discussed so many things, right? Like how to do the post processing, how to interpret the results. So you can like create a report by going through these various sections. You know, uh, this pipeline. In this pipeline, there are various options. Okay, and in the even in the FEA section also there are various options. So you can go through them and then create a sort of report. You're free to do it in any way possible, and just submit it so that I get some feedback on how much you are able to grasp. So accordingly, I can adjust the uh, complexity of the next task that we'll be doing in the subsequent section. So the first section, I'm just you should. I'm trying to make you comfortable with the use of software. As you can see, the software is very not too memory intensive, no, and if you compare to the other software, they are very memory intensive. It requires a lot of graphic memories and all those stuff. So in that way, this is good. All right. If there are no further queries, I think we'll end today's session for now. because I don't want to. Because the next modeling exercise is what I will just show you what I intend to do. All right. So next modeling exercise which we'll be doing is this. Okay. So as you can see how complex the geometry is. Next section will be on this. And other exercises also. All right. So shall we call it a day? If there are no more queries. All right, Vaishnavi, you can create that feedback and send it to the students. Just show me the feedback form before sending it to the students, and just discuss with Pawan sir. Like he might have done similar workshops and he might have some kind of format for the feedback exercise.
Yes,
So,
sir. Has
Yes,
been
yes.
sent.
Oh, yeah. Okay. Yes, somebody was asking
It
something.
so can we have the basic CAD files of these dimensions or something kind of that?
The
Uh,
dimensions. I will give you the dimensions of the model so that you can practice it at home. If you are not able, if you are not able to pick up, so I have the what do you say, the dimensions. I will give the dimensions. I will give it to Vaishnavi. Vaishnavi, I will give the dimensions of the raw dimensions of the part, and then you can distribute it on the group. Is that okay?
Yes, sir. Yes, sir.
All right. Anything else before we call it a day? All right, then. Thank you very much for joining the session. I hope I will see you tomorrow for the next session. All right. So just practice this so that it will help you to pick up this more complex exercises in the subsequent sessions. All right. Thank you.
Thank you, sir.
Thank you, sir.
Bye.
Thank you.
Thank you,
Thank you.
sir.
Thank
Thank
you.
you, sir.